we propose ReCaLab, a novel approach for photorealistic 3D avatar creation from monocular video and enabling different types of manipulations with the generated virtual avatar. We use a monocular video as input and aim to model neural humans with a disentangled neural texture field and enable different types of manipulation, which including novel view rendering, novel pose animation, and novel appearance with customized shape, texture, and illumination by language brush. Our approach takes monocular video frames as the input to reconstruct the human avatar. We first learn the backward deformation of the human body in Module A to map the 3D points between canonical and observation space. Then we learn to predict the UVS map via Module B and corresponding neural texture in UVS space via Module C. Finally, in Module D, shape, texture, and shading modules can be updated accordingly with the instruction from the language brush. We evaluate our approach first on ZJU mocap dataset and use PSNR, SSIM, LPIPS as the evaluation metrics. And compared with two SOTA baselines, HumanNeRF and UV volumes, our method achieves best performance on SSIM and LPIPS metrics for both novel view and novel pose synthesis. Here are some visualization examples for free view rendering with bulleting time effect. Here is the qualitative comparison for novel view synthesis. Our method provides more detailed texture thanks to the proposed disentangled neural texture learning. From the marked regions, HumanNeRF suffers from disentangled texture, while UV volumes arises additional deformation artifacts, and our approach copes with both issues. We also evaluate novel pose scenario on people snapshot dataset. The reconstructed human avatar is triggered by the reference frames, where our approach provides less artifacts compared with HumanNeRF. We use MDM to generate a novel pose sequence with the text instruction, "The person is jumping." Triggered by that, our approach provides sharper texture and fewer geometric artifacts compared to HumanNeRF. Our approach is capable of generating a consistent human body based on different text instructions, which enables fine-grained manipulation with the specific module, for example, shape editing with UVS module, relighting with our shading branch, and in the end, texture and appearance editing with our neural texture module. We compare the human avatar manipulation results. HumanNeRF-based manipulation baseline suffers both from a longer training time and lower performance. Our method generates better quality results with less artifacts. Thanks for watching.